Okay, substitution reaction. This is where we're going to literally swap functional groups around or swap hydrogen groups around. Okay? It's two reactions. And it's two chemicals that happen to do it. Sounds like what? Double replacement. Okay? So in an addition reaction, we have two compounds that form one. In an elimination reaction, we have one compound that forms two. In a substitution reaction, we have two compounds that create two new compounds. Nope, not at all. They just swap. Alcohols need to react with an acid. Same thing as an elimination. Alcohols must react with an acid. Okay? Alkyl halides react with a hydroxide ion, a strong base. Same thing as in an elimination. It needs a strong base in the presence of heat. In a substitution, an alcohol gets swapped with an acid, and an alkyl halide gets substituted with a strong base. They literally just swap. Okay? Let's look at ethanol. How many carbons in ethanol? This one, the reaction is with hydrochloric acid. Whoops. Okay, girls, unless you want 15 minutes of fame, I'd stop. What are we going to swap? The alcohols get swapped with the halide group in the acid. So we're going to get, again, two carbons. We're sticking with a single bond, but instead of the alcohol group, we're going to turn it into a halide group. And we end up with H, this hydrogen here, reacting with this hydroxide group here. So we get HOH, otherwise known as perfect. Okay? Second example. What's this guy called? Alkyl halides have to react with a hydroxide ion. So that's typically how you're going to see it. We could call it magnesium hydroxide if we wanted, if it helps you see the double replacement better. We are literally just going to substitute the bromine group for the hydroxide group. And then you get a bromine ion floating around. Okay? It will either say a strong acid or it'll tell you a specific acid. Or nitric, or sulfuric, or perchloric, or any of the top 6 acids. Okay? Typically, hydrochloric, or nitric, or sulfuric are the 3 most common strong acids used in industry. Okay, alkanes and aromatics can undergo substitution reactions as well, but since organic molecules are very stable, they require an energy to force them. So alkanes and aromatics. This is the only aromatic that we're familiar with right now. Put it away. There's a blanket right there. Okay? Alkanes undergo substitution reactions with a considerable amount of UV light. Okay, let's take this guy here. What's he called? What do we call that? Nope, this one here. Methane. This is the lesson where we talked about carbon tech. So 10, what is Cl2? Say it with confidence, Haley. Chlorine. Okay? We can also write it as this. This is the same thing. But we have to do it in the presence of UV light. And so we've got 10 of these guys here. Nope. There's 10 chlorine atoms there. I see why you're saying it, Declan, but it's 10. Even though it's chlorine and we only get 10 in total. Okay, and then we have some leftover ones floating around. I don't think so. Okay, in the last class we talked about this one here. This is a fire suppressant. Yep. Okay, it's called carbon tetrachloride and it was used as a fire suppressant. It's not anymore. It's now considered a hazardous substance. It's a carcinogenic. Okay, it's a cancer-causing agent. Now at the bottom of this page, there's a statement here that I'd like you to write. Okay, aromatic hydrocarbons will undergo a substitution reaction with chlorine or bromine only in the presence of a catalyst. Nope. I'll show you what it is. UV light is energy. What do we call this guy? It is what, Declan? It is. It's benzene. And in the presence of bromine, we need to add a catalyst. So what we're going to learn in the last unit, because typically organics is taught as the very last unit, I teach it first to ease your brain into Chem 30. What happens is we learn about catalysts, and catalysts lower the activation energy, and what that is the amount of energy for a reaction to happen. Catalysts reduce that amount of energy. Yeah. Yep. Okay. And so then we still get but instead of pulling having all of these be hydrogens, we now can have a bromine group. And the hydrogen here and the one bromine there that's left over will form hydrogen bromide, or in the presence of water, hydrobromic acid. Okay? Are we good so far? What do we call this guy? Our new compound. Bromobenzene. Do we have to put the 1 in there?
No, because it starts at the. Yeah, because it starts at one of the double bonds.
There's a double bond on any one of those carbons. It starts at the halide group. Yeah. Okay. Let's do a summary of all these guys. Okay. You'll have a few videos that you have to watch, Eric.
Yeah, we're leaving at 7.
Okay, let's look at the first one.
Yeah, so how long do you think that job's gonna last?
Well, seeing as how they don't know how to do anything.
Okay. How many number of reactants in addition? 2. And if we have, what are the 2 things that we're going to look at? Alkenes. Oops. Okay. How many products do we get in an addition reaction? And what are the 2 types of products we can get? Does it require any conditions for single in the first one? Alkenes? Nope. What about in the second one? Limiting or excess reagents. Okay. Did you complete your notes, Haley? Good job.
What's the word?
This one here, reagents. Reactants, reagents. What's the next type of reaction we learned? Here says reagents. Here, this says limiting, and this says excess. This says double or single bonds. No, limiting or excess reagents. They're just,
Yeah, just like that.
yeah. Okay, in an elimination reaction, how many reactants do we have? What are the two kinds of reactants that we can react?
Strong acids.
Well, you're close. What reacts with a strong acid, Declan?
Alcohol.
Alcohol, and we get an alkene, right? We get two products. We get alkene and water. And this is in, Declan said, in the presence of heat and a strong acid. What's our second reaction? What's the second kind of reaction we can have?
Alkaline. Strong base. Alkyne.
Alkyl halide. Okay, how many products do we get? Two. We're going to get an alkene and a halogenated product. So X stands for a halogen, and a halogen is what?
Like the gases on the website.
Group 17, right? So chloride, bromide, fluoride, iodine, those are the common ones. Acetine's also in there. What do we need for this reaction to happen? Heat and a strong base. Okay. Now we just talked about substitution. This should be fresh in our mind. Okay. We have three things that we can do here. Four. How many reactants do we need in a substitution? Two. Give me one. Alcohol and an acid. The acid has to have a halide on it. So hydrochloric, hydrobromic, hydroiodic. How many products do we get? Two. What do we get? We get an alkyl halide and water. Do we need anything for that reaction to happen? Do we need heat? Do we need energy? Do we need a catalyst? Nope. Okay, next one. How many reactants? All substitutions are two. Okay, what's the next kind of reaction we can have? Alkyl halide plus a strong base. How many products? Two. What are my products? They swap. So if I had an alcohol and I got an alkyl halide, and I will get whatever the halide ion is, right? Does this one take anything to have the reaction happen? No. Next one. These are the two ones that are stable, and we have to force it to happen. Benzene. Okay, so let's go. And we are going to react it with what, Declan? A halide. X2. Okay. How many products do we get? 2. If I was to go back here, I could put this bromine on any place, right? And if I had excess, I could put more than one bromine around it. I would, yeah. It depends. If this was in excess, I could get all of these happening all at once. Okay, I could get all of those happening all at once. So our answer in our chart is going to be many. Okay. What do I get? What's my product? Halogenated benzene. And what does it require to happen? A catalyst. What's the other one? If it's not a benzene that's stable, the other one is an alkane. And again, we can get many. And what are we going to get? And what does it need? UV light. This is where you need the UV light, Declan. Okay, last one that we haven't actually talked about, but we spent a whole lot of Chem 20 learning, is this one. Now you can talk about your photosynthesis and your cellular respiration, Declan. And you would be right. How many reactants are there? 2. There's your hydrocarbon and oxygen. How many products do you get? No. 2 very specific products when you do a combustion reaction. Right? It depends if it's open or closed, if they're gas or they're liquids. Do we need anything? Not heat. Generates heat. Okay? Let's look at this one here. What kind of reaction is this? What do we see? Do we see a double bond? So when I look up here, my reactants, where do I see a double bond? Addition. This is an addition reaction. So I'm going to end up with one product that's going to have a single bond. How many carbons in my main chain? And so I'm either going to see the chloride go here, or I'm going to see the chloride go here. And if it was in excess, it could be both. I could get this. And so how do I name this very bottom one? CH2, CH, CH3. And they've got 2 chlorines on there. How many carbons? Hey, let's look at this one. What do I see here as my functional group? Alcohol. So when I go through my list, what kind of reaction can this be? Okay, it can be an elimination or a substitution. How many reactants do we see? 2. This second one is an acid. So if I have an alcohol and an acid, this is a what kind of reaction? And so we'll literally substitute the halide for the halide for the alcohol. Hydroxyl group, yeah. It's the alcohol component. It's something out in the hallway and it's annoying. It's grade 7s being grade 7s. Okay, what if I had this? My product is an alcohol group. What would my 2 reactants be? A which? Nope. My product is an alcohol. No. Would we see another bond forming in addition? See a bond breaking. So, how many carbons in my main chain? And where do I see the alcohol group? On the second carbon. So from the second carbon, we can have a double bond, and we could make our, right? We only have one bond. If you wanted to look at elimination, you need two products, and you can't because those get double bonds. Substitution, you have to have two products, and we only have one product. The other place is that our double bond can come off of our first carbon. As long as the double bond is touching this second carbon, it doesn't matter if it's before or after it. So this is an addition reaction. Okay, 2-bromo-3-methylbutane. So how many carbons in my main chain? And on my second carbon, I have bromo. On my third carbon, I have a methyl group. And water. Oh, they're the products. Pay attention, Ms. Pyre. Declan, you shouldn't be writing in pen. You should know that by now. And water are the products. What are my reactants or reactant? I have two products. One of them is a halide, so that can be substitution, substitution. That's what I got. So chances are this is a an alkane plus X2. Does that give me water as a product? An alcohol plus a halogenated acid. So plus a halogenated acid. Could be. It would be. Yep. You're right, Eric. Again, Miss Pyre needs to pay attention. Okay. So here's the Br that's going to switch off. And then this hydroxyl group is right there. And here's our hydrogen. Ends up right there. Okay. Let's try these practice problems.